learner. Hope you are doing well. My name is Bataringa Adam, a teacher of Mathematics P5 from Ruatura Primary School. Before I have a short story here. In my home area, my father had a rectangular piece of land. Last week, as UNRWA was widening a feeder road near that land, it affected it diagonally. Hope according to that, that short story, you can identify the shape. That remained. I hope you have guessed that it is a triangle, and which that triangle is a right-angled triangle. Apart from the shape mentioned, we have other shapes. We have a circle, of which a circle is of this nature. This is a circle. We have another shape, a trapezium, and this is a trapezium I'm talking about. We have another shape like a kite, and this is a kite I'm talking about. We have another shape like a cylinder. Hope you can see how the cylinder looks. This is my cylinder. We have another shape like a rectangle. You can see it is a rectangle and it is of this nature. We have another shape like a square. As you can see. I think you're observing their properties and everything. So those are some of the shapes I can show you. We are looking at a topic as length, mass, and capacity. And a subtopic, we are looking at finding area of a triangle. A triangle is a three-sided shape. As I can illustrate a shape of a triangle, triangles, they have many kinds. We have the scalene triangles, we have the isosceles triangles, but specifically, if we are to look at finding area of a triangle, we are looking at a shape of a triangle which is having a right angle. For example, we have a triangle here that the time that we should be finding its area is this right angle. We may find that it is one part, or at times it is double. We may find it is like this, as I'm illustrating here. So, we may find it is one part like this, or they are double parts of a right angled triangle. And also what the time that we should be finding the area here is having the right angles. Therefore, when I talk about that we are finding area of a triangle, I mean the shape, either the shape of this nature or this nature, as long as it possesses a right angle. Learners, these triangle have the major name sides. We can see that this side can be named as the base. This side can be termed as the height, and this side is called hypotenuse. Likewise, when you reach here, the whole of this one can be termed as the base. Then this one can be termed as the height. Then this one can be same applies, be termed as hypotenuse. After identifying this, the specific triangle we want, now we are to develop a formula of finding the area of these triangles. In our formula, I'm trying to develop that formula. These right-angled triangles can be developed in some shapes. Can be developed from a rectangle or from a square. Because that's why in its formula, somewhere there is something like a half. For example, you may be having a square of this nature when it is combined. But when I make it half by folding it diagonally, I can form two right angles. So therefore, if it is a square, and I remove, and I try to fold it diagonally, then also here I cut it. Then when I remove it, the one which was a square, I can develop two right-angled triangles. Same applies if it is a rectangle, same applies. And I'm bringing in the knowledge of knowing that the area of a triangle is a half times base times height. Due to the fact that after dividing this square into two, making it a half, and I got these two right-angled triangles, then I can come here and develop that in order to find the area of this triangle, area of a triangle equals a half times base times height. And you have to make sure that under the guidance of the formula, even though on a triangle we are having another side which is called hypotenuse, but it is not applied anywhere because it is not in the formula. For us, what we are interested in, we are interested in the sides which are mentioned in the formula. So our formula, the formula for finding area of a triangle, any triangle, as long as it possesses a right angle inside there, area equals a half times base times height. Well, we can have examples. We can have examples. So example 1. Examples. 1. Find the area of a triangle below. And it is illustrated here. The triangles here, as illustrated on the chalkboard, they want us to find the area. And as we have stated, that a formula for finding area of a triangle, that area equals a half times base times height. We are interested in a base and height. So as we have stated, the area of a triangle equals a half times base times height. Then the next step is the substitution stage. We can see what are we having on the base and what are we having on the height. So we are having area as a half times the base, which is 8 centimeters, times the height, which is 6 centimeters. Please, you have to make sure that you go with the units. If you are given centimeters, try to use centimeters. If you are given meters, try to use meters, because here we can use different units. But here right now we are given centimeters, and as you can see, we are having a half times 8 centimeters times 6 centimeters. Possibly here, where the factors can be reduced, I can reduce this 2 by 2. This is 1 by 2 here. This is 4. I'm left with area as 4 centimeters times 6 centimeters. Then 4 centimeters times 6 centimeters. Here, we may end up having area. When we have 4 times 4, that is 24. 24. But centimeter times centimeter, you get centimeters squared. When you are writing as a symbol, you write as centimeters squared. But when you are reading it in words, you can read it as square centimeters. But yet we are writing as a symbol, we shall say that is 24 centimeters squared. And this will be the answer. That is example 1. Example 2, this one we are doing it together. We look on the figure. As I write, you are trying to find the right submission according to the answer of the question we shall be given. So find the area of a triangle below. And the triangle is illustrated as I'm showing you here. Given hypotenuse, they are not involved in the. So in case you are given those ones, don't mind. Number 2, here when they want the area and you are given the base of this nature, this 13 meters, serves from here up to here, serves for the whole base. So therefore, we substitute as normal, and we say that area equals a half times base, a half times the base, which is 13 meters, times the height, which is 8 meters, Therefore, here we can reduce. We are allowed to reduce in case there is a possibility of reducing. Here, we can divide here by factor 2, here by 2, this is 1. Here by 2, this is 4. Therefore, we are left with area as 13 meters times 4 meters. We are having 13 times 4 here. We can have side work 13 times 4. 4 times 3, that is 12. We write 2 and keep 1. 4 times 1, that is 4, plus the other one, which is 5. Therefore, here we are having area as 52 meters squared. So here we have maintained the units of which we found on a triangle given. That's why I'm ending up with 52 meters squared. Now, basing on these two examples given, we are going to have an exercise about these examples given. So, exercise. We are doing that. Find the area of the following. Find the area of the following triangles. Part A, you are having the first triangle as I'm illustrating it here. You are having part C as the last. Here is the exercise we are supposed to do, and work them according to how we have done these examples. Follow the same rules on how to work them, whereby we say that use the units properly. Instead, here we are in decimeters, and you try to use centimeters, the answer is wrong. It means that you are marked wrong. Please use following the given units to work out the given triangles. Then number 2, the area of this figure is in centimeters squared. That should be squared. So in case you don't put squared, it means that also your answer is marked wrong. So do these numbers, shall add on